that was something I had a question for you about. But the other one was, um, the can you just briefly describe how he measured velocity against absolute space?
Yeah. So their conceptualization of linear motion and being able to not use light to measure it, meaning if you split a light beam such that it completes a circuit and comes back on itself, that it'll be out of phase in proportional to the velocity that caused it to be out of phase, right? Now, when they did Michelson-Morley, they predicted that it would be out of phase by a specific amount that would be proportional to 30 kilometers a second. Because remember, in their philosophy, in mathematics, their velocity is mandatory of 30 kilometers, and they knew that they could measure light and they could use this fringe shift pattern relationship to get a velocity out of it. So when they took the measurements, they didn't get the measurement that they needed. They got a much lesser value, but still higher than what was considered to be like experimental error. So they ended up just saying, okay, well, we'll just say it's experimental error anyway, and we'll say that linear motion actually doesn't cause a phase difference, and that's where they built the theory of relativity. Well, it was actually Lorentz's theory first. And it was basically saying that, the reason that you can't measure linear motion is because the bodies are moving through a static ether and it's like compressing the molecular structure of the body proportional to the square of the velocity squared, which is like, a fraction of a fraction of a fraction of a fraction kind of thing. So that's where they get like the time dilation gamma factor that was originally link contraction and time dilation due to ether compression, essentially. Now, Einstein came along and was like, well, we actually don't need an ether. We can just say that time and space are not absolute. And because of that, all motion is relative. And because all motion is relative, it'll be independent of the light motion, or I mean, it'll be independent of the speed of light. So you won't be able to use light to measure linear motion. So they built this whole framework on it and described it in a way that basically says that there will be no phase difference produced in a split light beam that's moving in a straight line. So Wang, using a parallelogram configuration, which I'll put up in a diagram here in a second so you guys can see it, it was configured in such a way that the bottom part is stationary and the arms leading up to the top of the parallelogram wiggle back and forth, so they would cancel each other out, so there's no motion there, and then it would just be the motion of the top part. And what he did to derive the fringe shift pattern for this specifically is he used the total length of just the top portion of the fiber optic cable. Now, some people will say that, well, this measurement is with respect to the apparatus that's stationary in the lab frame or whatever. Now, if that were true, you would have to derive it with the total path length. There would be that would change the amount of fringe that's measured in that linear portion drastically. Like it would be a different measurement. So the fact that he predicted it with just that linear portion shows that it's not with respect to the entire fiber loop going to the detector, meaning that stationary portion right there. It's what's happening is when that fiber is being moved, you can think of it like a snapshot is being taken right there. And then as that length is moving to, its new location, that the entire length of it is being preserved. So instead of being in the same spot, it's now like longer essentially, right? And now that it's longer, light had to travel longer. So light somehow is like preserving this reference where the origin of motion started to where it ended, and it's measuring the timing difference proportional to that velocity in both directions, going with and against the motion. And they say that that explicitly can't happen because otherwise, that would mean that the Earth is stationary, or that would mean that the Earth is moving at 6 to 8 kilometers a second, which isn't tenable for their mathematics and philosophy either.
Damn. I'm glad I told him short description. No, I'm picking with you, dude. That's funny. Nice, nice fucking breakdown, dude.